Have you ever wondered what lies beneath your feet? No, not just rocks and dirt, but deep down, thousands of kilometers into the very core of our planet. What would it take to dig straight down, through soil, solid rock, liquid metal, all the way to the center of the Earth? It sounds like a science fiction adventure, descending through miles of crust, mantle, and core, witnessing alien landscapes never seen by human eyes. But there's a reason this dream remains impossible. Today on Amazing World, we're digging deep, really deep, to answer one of humanity's oldest questions. Why can't we travel to the center of the Earth? Imagine this. Jules Verne's classic novel, Journey to the Center of the Earth, came out in 1864. Since then, we've crossed oceans, flown to the moon, sent robots to Mars, even probed the far reaches of our solar system. Yet we've barely scratched the Earth's surface compared to its total depth. How deep have we actually gone? Why is it so difficult? And what terrifying obstacles would we face if we ever tried? Get ready, because we're about to descend into the deepest rabbit hole you've ever known. Before we figure out why we can't reach the center, let's first understand how deep we'd need to go. Earth is roughly a sphere with a radius of about 6,371 kilometers. That's nearly 3,959 miles. So, the distance from the surface to the center is the same, 6,371 kilometers. Sounds simple, right? Just dig down 6,371 kilometers. But here's the twist. We've never come remotely close. In the 20th century, the Soviet Union attempted the deepest drill ever, the Kola Super Deep Borehole. Located on the Kola Peninsula near the Arctic Circle, this ambitious project started in 1970. Over the next 24 years, Soviet scientists drilled a hole that reached an astonishing 12,262 meters. That's 12 kilometers, or about 7.6 miles. It remains the deepest human-made hole on Earth to this day. But here's the kicker. If Earth were an apple, the Kola Super Deep Borehole didn't even pierce the skin. Compared to the 6,371 kilometer radius, that tiny 12 kilometers hole equals just 0.19% of the distance to Earth's center. So, why did they stop? The team had hoped to drill 15 kilometers down, but they ran into staggering problems. First, there was the heat. At that depth, temperatures soared to 180 degrees Celsius, 356 degrees, nearly 80 degrees hotter than they had expected. The deeper they drilled, the hotter it got. The intense heat softened the surrounding rock, making it behave more like plastic than solid stone. This caused the borehole walls to slowly collapse in on themselves. Then there was the pressure. Down there, it reaches about 300 times the atmospheric pressure at sea level. The machinery they designed struggled to function in this hostile environment. Even their drill bits warped and broke under the immense stress. This was just 12 kilometers down. Imagine what happens at hundreds or thousands of kilometers deeper. To understand the challenge, let's take a quick tour of Earth's interior. Scientists divide Earth into 4 major layers: the crust, the mantle, the outer core, and the inner core. The crust is Earth's outermost shell, solid, brittle, and relatively thin. Under continents, it's about 30 to 50 kilometers thick. Beneath the ocean floor, it's even thinner, around 5 to 10 kilometers. We've barely penetrated this layer. Beneath the crust is the mantle, which extends down to about 2,900 kilometers. The mantle is mostly solid rock, but behaves plastically over geological timescales. It slowly flows, driving the movement of tectonic plates. Below the mantle is the outer core, a vast ocean of liquid iron and nickel that generates Earth's magnetic field. It ranges from 2,900 kilometers to 5,150 kilometers beneath the surface. Finally, at the very center is the inner core, a solid sphere of iron and nickel about 1,220 kilometers thick. Temperatures here reach a mind-boggling 5,400 degrees Celsius, 908 array, hotter than the surface of the sun. So what makes it impossible to reach these depths? Heat is the first major obstacle. The deeper you go, the hotter it gets. This is called the geothermal gradient. On average, temperature increases by about 25 to 30 degrees Celsius per kilometer. By the time you reach the bottom of the crust, you'd already be facing temperatures of 600 to 200 degrees Celsius. The Kola borehole team discovered this the hard way. The unexpected heat caused the drill to fail repeatedly. Our best drilling equipment today simply can't survive these extremes. Steel drill bits melt or deform. Lubricants vaporize, electronics fail. To drill deeper, we'd need materials and cooling systems that don't exist yet, capable of withstanding temperatures that rival molten lava. Next up, pressure. Every meter of rock above you adds weight. At a depth of just 12 kilometers, the pressure is already around 400 megapascals. That's about 4,000 times atmospheric pressure at sea level. At the center of the Earth, scientists estimate the pressure reaches 360 gigapascals, more than 3.6 million times what we experience on the surface. Under these pressures, rocks are squeezed like putty. The borehole walls tend to collapse. Equipment can buckle or jam. It's not just about building stronger drills. We'd need ways to keep the tunnel stable and open under these crushing forces. Suppose you could somehow survive the crust. Now you'd have to drill through the mantle, which makes up about 84% of Earth's volume. The mantle isn't just super hot, it's also composed of ultra-dense rock that flows slowly over millions of years. This flow means any hole you create would close in behind you. Add to that the constant risk of earthquakes, magma pockets, and unpredictable rock compositions, and the mantle becomes an ever-shifting, impossible barrier. But let's play along. What if you manage to get through the mantle? Next up is the outer core, a sea of molten iron and nickel. No known drilling technology could function in liquid metal. There's no solid wall to bore into. It's more like trying to dig through a raging underwater volcano of molten iron at 4,000 to 6,000 degrees Celsius. Even if you could invent some sort of spaceship-like craft to descend through this ocean, the extreme heat and pressure would vaporize any material we know. At the very center lies the inner core, a solid ball of iron and nickel. This solid core spins inside the liquid outer core and is responsible for maintaining Earth's magnetic field. Temperatures here are estimated to be hotter than the sun's surface. The iron is solid only because the pressure is so high that it forces atoms into a crystalline structure. No machine, no matter how advanced, could maintain its integrity under these conditions. The laws of physics, not just engineering, are stacked against us. Over the years, scientists have dreamed up radical ideas to reach deeper into Earth. One proposal involved drilling from the ocean floor, where the crust is thinner. The famous Project Mohole in the 1960s aimed to drill into the mantle by starting from the seabed. But even then, they only reached 183 meters below the seafloor before funding ran out. Some have suggested using nuclear explosions to blast tunnels through the rock, but the environmental impact and unpredictability make this idea wildly impractical. Others wonder if we could use naturally occurring cracks or magma chambers, but these are unstable and dangerous. If we can't get there, how do we know what's inside Earth? Scientists rely on indirect evidence. The most important tool, seismic waves. When earthquakes occur, they send shock waves through the planet. By studying how these waves travel and where they reflect or bend, geologists map out the different layers. Seismic waves slow down or speed up, depending on the materials they pass through. Some waves can't travel through liquids, which is how we know the outer core is molten. Meteorites, which are fragments of other planetary bodies, also give clues. since they often contain iron and nickel, similar to what we believe makes up Earth's core. And finally, computer models and lab experiments replicate conditions at extreme heat and pressure to refine our understanding. So, will humans ever reach the center of the Earth? Maybe, but not anytime soon. The technology required would have to withstand unimaginable heat, crushing pressure, and ever-shifting rock. It would need to be self-repairing, ultra-durable, and capable of somehow cooling itself constantly, while boring through thousands of kilometers of solid and liquid rock and metal. Futurists dream of nanotechnology, quantum tunneling, or self-healing materials that might one day make this possible. But for now, it remains squarely in the realm of science fiction. So, next time you're walking on the ground, remember, beneath your feet lies a vast alien world we can't reach. Despite our best efforts, the center of the Earth remains one of the final frontiers, untouched, unseen, and still full of mystery. We may not be able to travel there physically, but our curiosity will always drive us to explore, to understand, and to push the boundaries of what's possible. Who knows what secrets lie hidden, waiting to be discovered by the explorers of tomorrow? If you enjoyed this deep dive into the hidden world beneath our feet, don't forget to like, subscribe, and hit that bell icon so you never miss another adventure from Amazing World. Have ideas for other mysteries you'd like us to uncover? Drop them in the comments below. Until next time, keep exploring, keep asking questions, and remember, our world is more amazing than you ever imagined.